Hello everyone. So I'm going to go over the using models to balance an equation worksheet. You can see in this first example here that we are first going to count our atoms. So this is the chemical reaction that we're working with. Here is HCl, hydrochloric acid. You can see that in terms of our hydrogen, we have hydrogen in two places here. We've got it in the NaOH and we have it in the HCl. So we do have two atoms of hydrogen going in. If we look here in our H2O, we have two atoms of hydrogen coming out. Then if we take a look at our sodium, we have one sodium in the NaOH here going in, and we have one sodium in the NaCl coming out. Then if we take a look at our oxygen, we have one oxygen going into our chemical reaction, and we have one oxygen in the water right here coming out. Then for our chlorine, we have one chlorine going into our chemical reaction, and then coming out, we have one chlorine right here coming out. So what that means for us is that this chemical reaction is balanced. We have one sodium in, one sodium out, one oxygen in, one oxygen out, two hydrogens in, two hydrogens out, one chlorine in, one chlorine out. So that's what we're checking for when we do our atom counts. So this chemical equation is balanced. You do not need to add any coefficients in order to balance it. What we do need to do is we need to identify what kind of reaction this is. And this is a double replacement reaction. Okay, we've got a compound and a compound. And what we see happen is the hydrogen and the sodium switch places with each other. Now, for the remainder of this, you can model it, you can draw it, or you can just do atom counts. So if I start with doing atom counts, I start with two hydrogens going in, and I only have one hydrogen coming out. So I know it's not balanced. In terms of chlorine, I have two chlorines going in, and I only have one chlorine coming out. So visually, what we see happening here, if we were to draw this, we have two hydrogen atoms going in, and we have a molecule of HCl coming out. And we have a chlorine molecule going in. So we can see now we're not equal. Well, when we put in a coefficient, what we're doing is we're making more molecules. So if I put a 2 in front of the HCl, what that means is that I have another molecule of HCl. So that means that I now have two hydrogen atoms coming out and two chlorine atoms coming out. And so, since I now have two going in and two coming out, I now can see that I am balanced. Two hydrogen atoms in, two hydrogen atoms out, two chlorine atoms in, two chlorine atoms out. So after balancing, I now have everything equal. 2, 2, 2, and 2. Type of chemical reaction, this is a synthesis reaction because two are becoming one. If we go down to the next one, we're going to do the same thing. We're going to count our atoms. We've got magnesium, one of them going in, and then we have oxygen, two atoms of it going in, because this is a molecule. In terms of coming out, we have a magnesium bonded to an oxygen. So that means that we've got one magnesium atom and we have two oxygen atoms. So, one oxygen atom. So we're not balanced. So we put a coefficient in front. We need more oxygen coming out. So what that means is we now have two molecules of MgO. So that means we now have two atoms of oxygen. We also have two atoms of magnesium. So now we need more magnesium. So we're going to put a 2. So that means that we now have two atoms of magnesium. And we still have our two atoms of oxygen. So now we can check and see we are balanced. Two magnesium in, two magnesium out, two oxygen in, two oxygen out. We did that by putting a 2 in front of the magnesium and a 2 in front of our magnesium oxide. type of reaction that this is a synthesis reaction. Next one's a little bit tougher. Combustion reactions can be hard. Let's start with our atom counts. Carbon, we have 2 of them. Hydrogen, we have 6 of them. And oxygen, we have 2 of them for going in. In terms of coming out, carbon, we have 1 of them. Hydrogen, we have 2 of them. And oxygen, we've got to be careful. We have 2 of them over here. And we have 1 of them over here. So we have 3 oxygens total. So now what we do is we're going to put our coefficients in front. I start with carbon and hydrogen usually. So carbon, if I put a 2 in front of CO2, remember that that means that we now have 2 molecules of CO2. So that is going to change our oxygen count and our carbon count. So we now have 2 carbons, and we now have 2, 4, 5 oxygens. Now I'm going to fix my hydrogen. I'm going to put a 3 in front of the H2O. So what that means is that, remember that I now have 3 of these H2O molecules. So that means that I now have 6 of my hydrogen, but now I've also changed my oxygen counts. I now have 7 as my oxygen count. Now here's the problem with this particular problem. It has to be an even number, because every time I make another oxygen, it's going to be in multiples of 2. So for example, if I put a 2 here, then that means I've got 4 oxygens. If I put a 6 here, then that means that I've got 12 oxygens. So I need an even number. So here's the little trick for this guy. We're going to double this to a 4. We're going to double this to a 6. We're going to change our carbon count. We now have 4 carbons. We're going to change our hydrogen count. We now have 12 hydrogens. We're going to change our oxygen count. We now have 14 oxygens, an even number of them. So how do I fix carbon and hydrogen over here? On my inside, I put a 2 in front. That's going to give me 4 carbons going in. That's going to give me 12 hydrogens coming out, which is great. 4 and 4 and 12 and 12. And then that's nice and easy. If I put a 7 in front of the O2, that means I have 14 oxygens going in and 14 oxygens coming out. So that is the toughest one. This is a combustion reaction. Okay. Then the next ones are pretty easy. We're going to do potassium 1 going in, potassium 1 coming out, iodine 1 going in, iodine 2 coming out, bromine 2 going in, bromine 1 coming out. So we're not quite even. I'm going to fix my iodines first. I'm going to put a 2 in front of the Ki. That's going to give me 2 potassium and 2 iodine. So my iodine is balanced. I'm going to put a 2 in front of the KBr. That's going to give me 2 potassiums coming out. That's also going to give me 2 bromines coming out. And that means that everything is equal. We can see each of them have 2. This is going to be a single replacement reaction. Next one, hydrogen. We're going to do our count. 2 going in, hydrogen 2 coming out, carbon 1 going in, carbon 1 coming out, oxygen 3 going in, oxygen 3 coming out. Careful, there's 2 of them here and 1 of them here. So great news, that makes this balanced. This is a decomposition reaction. Then we've got our next one, calcium. I've got 1 going in, calcium, I've got 1 coming out. Hydrogen, I have 2 going in. Hydrogen, careful, we've got 2 here and 2 here. So we have 4 coming out. Then we've got oxygen. We have 1 going in. Oxygen, we have 2 coming out. So I'm going to fix my hydrogen first going in. If I put a 2 in front, that's going to give me 4 hydrogens going in, and that changes my oxygens to 2. So if I check now, I've got 1, 4, 2, and I have 1, 4, 2. So that means that's all I need to do is put that 2 in front there of the H2O. This is going to be a single replacement reaction. Next one, again, atom counts. Potassium 1 going in, potassium 1 coming out. Chlorine, I've got 1 going in. Chlorine, I've got 1 coming out. Oxygen, I have 3 going in. Oxygen, I have 2 coming out. So again, remember the little trick. We've got a 3 here and a 2 as a subscript here. So it's got to be a number that's a multiple of 3 and 2. So I'm going to want to get 6 oxygens going in and 6 oxygens coming out. So I'm going to do that by putting a 2 in front of KClO3 and putting a 3 in front of the oxygen. Now I need to change K's I have 2 of, Cl's I have 2 of. K's going out I need to fix. So I'm going to put a 2 in front so that way I have 2 potassiums going in and I have 2 coming out. So I see 2, 2, 6, 2, 2, 6. I'm now balanced. This is going to be a decomposition reaction. Finally, the last one, we start with our counts. Carbon, I've got 1 carbon going in. I have 1 carbon coming out. Hydrogen, I have 4 hydrogens going in. I have 2 hydrogens coming out. Oxygen, I have 2 oxygens going in. I got to be careful. I've got 2 oxygens here and 1 oxygen here. So I have 3 of them coming out. So the first thing I'm going to do is I'm going to fix my hydrogens. So I'm going to do that by putting a 2 in front of the H2O. When I do that, that gives me 4 hydrogens coming out. I have 4 hydrogens going in, so that's good. I also change my oxygen counts now, though, because remember, I've got 2 of them here, and then 2 times 1 is another 2 of them. So I've got 2 plus 2 more means I have 4 of the oxygen atoms coming out. So if I put a 2 in front of my O2 here, that's going to give me 4 of them coming out. I still have 1 carbon going in, 1 carbon going out, 1, 4, 4, 1, 4, 4. I am now balanced, and this is a combustion reaction.